Hi there and welcome to Mr. Fisher's Science Podcasts. This podcast is an introduction to chemistry. So let's look first of all at the atomic theory. Within the atomic theory we can identify that there are subatomic particles that make up an atom. There are three main types of subatomic particles. Those are protons, neutrons, and electrons. And really, this work was done largely by a group of scientists who worked separately to discover the main properties of the atom. And those scientists were Thomson, Rutherford, Bohr, Moseley, and Chadwick. And they were the big players when it came to understanding subatomic particles. Now, the Bohr model of the atom, which we'll look at in another podcast, is a really good representation of how electrons travel and how the atom is structured. And it suggests that electrons travel in a circular orbit or energy level. So the modern atomic theory states that an atom consists of protons, and protons are positive charged particles. They have a mass of 1 atomic mass unit, or AMU, and they're located in the nucleus. So protons being. Neutrons are also located in the nucleus. They have no charge, but they also have a mass of 1. Remember, that's AMU, atomic mass unit. Electrons. Electrons are located around the nucleus, and they're located in orbits. They have a negative charge. Their mass is so small that we consider them to be near zero, or consider them zero. It's about 1/2000th the mass of a proton. And so electrons would be located here, outside of the nucleus. So we can imagine that an atom consists of a dense nucleus surrounded by electrons moving in space. And this diagram here is a good representation of an atom. We can make out the dense nucleus, and we can make out the electrons orbiting around it. So let's look at the nucleus. Within the nucleus, we see that protons have a positive charge, and neutrons have no charge. So the total mass of an atom is equal to the mass of the protons and the neutrons. So for example, if we were to look at a carbon atom is made up of 6 protons and 6 neutrons. So 6 protons would have a mass of 6 AMU, and 6 neutrons have a mass of 6 AMU. And so the mass of carbon is going to be equal to 12 AMU, or remember that symbol. Electrons. Electrons move around the nucleus in paths called energy levels. Electrons have a near zero mass, and they have a negative electric charge. And in order for an atom to be neutral, really the positives and the negatives have to be the same. Which means that if I have 6 protons within a carbon atom, then I also have to have 6 electrons in that carbon atom in order for it to be neutral. Now, not all atoms are neutral, but we'll get into those when we talk about ions. Now, looking at electrons, they occupy energy levels depending on the atom. So for example, a hydrogen atom has only 1 electron because it's got 1 proton. Remember, protons and electrons need to be the same in order for it to be neutral. And we find that electron in the first, what's called the first orbit. Now, an atom can have a maximum of 2 electrons occupying the first energy level, 8 in the second, and 8 in the third. And each energy level must be filled before electrons occupy the next one. So if I look at a sodium atom, for example, a sodium atom has 11 protons, so it's also got to have 11 electrons. And the way that we go about filling these electrons is we find 2 of those electrons in the first orbit. Remember, the first energy level has a maximum of 2. Now we need 8 in the next energy level. So 1, 2, 5, 6, 7, 8. Those are our 8 electrons. And so now we filled it up. And the last energy level, we have 1, because remember, we only have 11 electrons. We could have a maximum of 8 in this energy level. And I put the periodic table here to show us how we go about figuring it out. If we look horizontally along the rows, we can count the number of atoms in the first couple rows, and that tells us the energy level, but also tells us the maximum number of electrons. So for example, in the first energy level, we have 1 and 2 elements, and so we have a maximum of 2 electrons. If we were to look at the second row, we can count the number of elements, so 1, 2, 4, 5, 6, 7, 8. So the maximum would be 8. Again, if I look at the third row, I also have 8 electrons, and so the maximum is 8. And that's a quick check to tell us how many electrons can fit in. Now it gets a little bit more complicated when we move down here, but the concept is still the same. So let's talk about atomic number. Atomic number was developed by a fellow by the name of Henry Moseley, and it's equal to the number of protons in the nucleus. Now the atomic number is very special because it's used to identify any known element. And the atomic number is found in the periodic table. So if I look at an element here, this element, it's got 6 protons. And remember, the atomic number is equal to the number of protons. So if I have 6 protons, then my atomic number is 6, and my element is right here. It's carbon. So this is a carbon atom. So I can use the atomic number to not only locate which atom I have based on the number of protons, but I could also do the reverse. If I know, for example, that I'm looking at maybe titanium here. Titanium is atomic number 22. And so titanium has 22 protons in the nucleus. So that's a quick way to tell the number of protons. So all atoms have a mass number. And the mass number is equal to the protons plus the neutrons. And this is a very handy formula that we can use to calculate the mass number. We can also do something else with this. We can calculate the number of neutrons. So going to our carbon atom, carbon has an atomic number of 6. Carbon has an atomic weight. Now notice it's 12.01. What I want to do to find the mass number is I need to round the atomic weight. So my mass number for carbon is going to be 12. Now to calculate the number of neutrons, well, that's simply going to be taking my mass number and subtracting my atomic number. And I get 6 neutrons. Let's try it with another atom. Let's try it with uranium. Uranium has an atomic weight of 238.03. Uranium has an atomic number of 92. Try and calculate the number of neutrons that I'd find in a uranium atom. So when we do that, we can take this number here, convert it into a mass number. Remember, we round it, so 238, and subtract 92, and we should get an answer of 146 neutrons. So, to sum everything up, to determine the number of subatomic particles, the number of protons is equal to the atomic number. The number of electrons is equal to the number of protons. So electrons equals protons. And to find the number of neutrons, remember I take the mass number and I subtract the atomic number. So let's look at an example. Mercury has an atomic number of 80 and a mass number of 200. What is the number of protons, neutrons, and electrons in one atom of mercury? Well, if we were to figure out protons, remember protons is equal to the atomic number which is 80. So we have 80 protons. Electrons is equal to protons, which is also 80. And neutrons, to find those, they're equal to the mass number minus the atomic number. So in our example, we have a mass number of 200. We're going to subtract the atomic number of 80, and our neutrons is equal to 120. And that concludes the podcast on and review looking at the atomic theory. And I hope that was helpful.